Defects in welding. In candor to produce quality weld joints, it is necessary to keep an eye on what is being done in 3 different stages of the welding. Before welding, such as cleaning, edge preparation, baking of electrode, etc., to ensure sound and defect-free weld joints. During welding, various aspects, such as manipulation of heat source, selection of input parameters, pressure of oxygen and fuel gas, welding current, arc voltage, welding speed, shielding gases and electrode selection, affecting the heat input, and so melting, solidification and cooling rates, besides protection of the weld pool from atmospheric contamination. After welding steps, if any, such as removal of the slag, cleaning, post-welding treatment, welding errors and failures. Lack of fusion. Lack of fusion occurs when there is no fusion between the weld metal and the surfaces of the base metal. Lack of fusion is caused by too low current, too high welding speed, incorrect torch/gun angle, incorrect angle preparation. There is no efficient, non-destructive method. Visual inspection can be used during welding and with bend test. Also ultrasonic testing, liquid penetrant test, or magnetic particle testing methods can be applicable. Welding errors and failures, incomplete penetration. This type of defect is found in any of 3 ways. When the weld bead does not penetrate the entire thickness of the base plate. When 2 opposing weld beads do not interpenetrate. When the weld bead does not penetrate the toe of a fillet weld, but only bridges across it. Welding current has the greatest effect on penetration. Incomplete penetration is usually caused by the use of too low a welding current and can be eliminated by simply increasing the amperage. Other causes can be the use of too slow a travel speed and an incorrect torch angle. Both will allow the molten weld metal to roll in front of the arc, acting as a cushion to prevent penetration. The arc must be kept on the leading edge of the weld puddle. Oguzhan-Vilmaz. Underfill. Incomplete joint penetration. This type of defect can be easily detected by visual inspection. Welding errors and failures. Undercutting. Undercutting is a defect that appears as a groove in the parent metal directly along the edges of the weld. Undercut minus. It is most common in lap fillet welds, but can also be encountered in fillet and butt joints. Overlap minus. This type of defect is most commonly caused by improper welding parameters, particularly the travel speed and arc voltage. Welding errors and failures. Porosity. Porosity is the result of gas entrapment in the solidifying metal. Porosity can take many shapes on a radiograph, but often appears as dark round or irregular spots or specks appearing singularly, in clusters, or in rows. Sometimes, porosity is elongated and may appear to have a tail. This is the result of gas attempting to escape while the metal is still in a liquid state, and is called wormhole porosity. All porosity is a void in the material and it will have a higher radiographic density than the surrounding area. Wormhole porosity. 17. Welding errors and failures. Inclusion. Solid inclusions are normally expected to be a subsurface type of defect and would include any foreign material entrapped in the deposited weld metal. The most common type of solid inclusion is a slag inclusion, defined as non-metallic solid material entrapped in weld metal or between weld metal and base metal. Welding errors and failures. Weld cracks. A crack is a fracture-type discontinuity characterized by a sharp tip and high ratio of length, and width to opening displacement. Cracks are perhaps the most serious of the defects that occur in the welds or weld joints in weldments. Cracks are considered dangerous because they create a serious reduction in strength. They can propagate and cause sudden failure. They are most serious when impact loading and cold temperature service are involved. There are many types of cracks: surface cracks, transverse cracks, longitudinal cracks, crater cracks, toe cracks, underbed cracks, welding errors and failures, distortion. Most of the welding processes involve heat. High-temperature heat is largely responsible for welding distortion, warpage, and stresses. When metal is heated, it expands, and it expands in all directions. Welding distortion or deformation or warping of weldments during welding is a natural outcome of intrinsic non-uniform heating and cooling of the joint. Distortion is the result of the action of internal stresses, which are produced while welding, and remain in the part after heating is removed, as briefly explained in the following. Imperfect shape detection. All shape defects can be determined by visual inspections. Linear misalignment. Cause. Incorrect assembly or distortion during fabrication. Excessive reinforcement. Causes. Deposition of too much weld metal, often associated with inadequate weld preparation. Incorrect welding parameters. Too large of an electrode for the joint in question. Spatter. Causes. Incorrect welding conditions and or contaminated consumables or preparations, giving rise to explosions within the arc and weld pool. Globules of molten metal are thrown out and adhere to the parent metal remote from the weld. Excessive penetration. Causes. Incorrect edge preparation providing insufficient support at the weld root. Incorrect welding conditions. Too high of current. The provision of a backing bar can alleviate this problem in difficult circumstances. Crater pipes. Resulting from shrinkage at the end crater of a weld run. Causes. Incorrect manipulative technique or current decay to allow for crater shrinkage. Weld defects, description and causes. Defect name description. Lack of side-wall fusion. Failure of weld metal to fuse to. Weld preparation. Lack of inter-run fusion. Failure of weld metal to fuse to preceding run. Lack of root fusion. Root bead fully penetrated, but not fused to root face. Poor restart. Cold start. Lack of fusion beneath weld start position. Lack of penetration. Failure to achieve the minimum penetration specified by design. Insufficient. Lack of root penetration. Failure of weld metal to penetrate fully root faces. Excess penetration. Unacceptable protrusion of the root bead. Root or face undercut. Notch parallel to weld at weld toe. Prevalent at top edge of PB fillet. Excess convexity. Excess weld metal on the face of A. Causes. Current too low, travel speed too high, incorrect torch angle, oxide film on prep surfaces, inadequate joint cleaning, weld preparation too narrow. Current too low, travel speed too high, incorrect torch angle, inadequate inter-run cleaning. Current too low, voltage too low, travel speed too high, root face too thick, root gap too wide, incorrect torch angle, inadequate cleaning. Incorrect welder technique. See section 7.4.1, poor earthing. Current too low, travel speed too high, incorrect torch angle, incorrect weld prep. Current too low, travel speed too fast, root face too thick, root gap too small, incorrect torch angle, misalignment. Current too high, travel speed too slow, root gap too wide, root face too thin. Current too high, travel speed too fast, incorrect torch angle, inadequate cleaning. Current too high, travel speed too low. Excess weld metal, excess cap height, incomplete fill face concavity or missed edge. Insufficient throat in fillet welds root concavity. Burn through. Overlap rollover, weld metal that has rolled over at the edges and not fused to the parent metal. Maybe face or root. Porosity gas entrapped in weld metal, giving a cavity. May be localized, uniformly distributed, or aligned. Wormhole piping. Crater pipe. Solidification cracking. Butt or fillet weld. Insufficient weld metal fill giving groove on weld face resulting in insufficient throat. Root pass sucked back to give a shallow groove. Localized loss of weld pool in root. Elongated gas cavity formed by solidification of large weld pool. Elongated cavity in the weld finish. Crater cracks in weld produced during welding. Incorrect torch manipulation. Poor welder technique, travel speed too fast, current too low, incorrect torch positioning. Current too high, root gap too wide, root face too thin. Current too high, travel speed too slow, root face too thin, root gap too large. Weld bead too large, current too high, travel speed too slow, prevalent in horizon-vert. Welds, inadequate cleaning. Dirty consumables, poorly cleaned or dirty weld preparations, contaminated shield gas, contaminated hydrogen containing, parent metal especially castings, oxide film on parent metal, porous gas hoses, leaks in gas delivery system, condensation, poor joint design trapping gas. See Chapter 2, excessive current, travel speed too slow. Incorrect welder technique, lack of crater fill. Incorrect choice of filler metal, failure to control dilution, incorrect edge preparation, crack susceptible parent. Defect name description. Crater cracking. Liquation cracking. Oxide entrapment. Puckering. 1. Tungsten or copper inclusion stray arc strike spatter. Underflushing. Short longitudinal or star-shaped crack in finish crater. Cracking in the has or in previously deposited weld metal. Oxide films trapped within the weld metal. Excessive oxide entrapment from weld pool turbulence. Accidental contact of the electrode TIG, or contact tip MIG, accidental arcing outside weld prep. Droplets of weld metal expelled from weld pool. Thinning below design thickness. Causes. Metal, high restraint, high heat input. See Chapter 2. Incorrect welder technique, lack of crater fill. Incorrect filler metal, crack-sensitive parent metal, high restraint, high heat input. See Chapter 2. Oxide films in or on parent metal, oxide films in or on filler metal, oxygen in shield gas, poor gas shielding, inadequate cathodic cleaning. Poor gas cover, very high weld current. Poor welder technique, incorrect mechanized setup. Welder carelessness. Poor welder technique, incorrect weld parameters. Excessive grinding.